Oh, welcome and thank you for joining. In this lesson, we'll explore simplifying rational expressions. First, let's start with some definitions. A rational expression is a fraction that contains algebraic expressions. The denominator in a rational expression contains a variable. The numerator may be any algebraic expression or a constant term. So as you can see, the denominator has to contain a variable, so it has to have an algebraic expression, whereas the numerator can be either an algebraic expression or a constant term. So the denominator is not allowed, in other words, to have just a constant term. So you might be wondering, why not? So let's take a look at a fraction or a rational expression with the denominator in constant form, 6x squared plus 10 over 2. So if you were to simplify this, then we would get 6x squared divided by 2 plus 10 divided by 2. And furthermore, this simplifies to 3x squared plus 5. And as you can see, 3x squared plus 5 is a simple polynomial expression. So it does not qualify to be a rational expression. On the other hand, if we had an expression such as 6x squared plus 10 divided by x plus 4, then we would say that this is a rational expression because it has an x in the denominator and it does not simplify to any other type of expressions. So when we talk about rational expressions, there are a lot of interesting features to talk about and discuss. And I'm going to start with the restriction story. So remember that when we divide two numbers, it is very easy to evaluate the answer. So we can use a calculator to divide just any number out there, or mental math, by simply dividing the numerator with the denominator. So 20 divided by 5 would be equal to 4. 1 divided by 2, that is 0.5. 6 divided by 0.01, I think this is going to be 600. 135 divided by 3, well, in this case, I would say that 3 goes into 13 4 times and then into 15, 5, so 45. And 9 divided by 7, I would need a calculator in here in order to find the exact value of it. So 9 divided by 7 is 1.28, the decimal value, not the exact value, sorry, my bad. So 1.2857, all right? And you can round it to as many decimal places, obviously, as required or described. So I would round to 1 decimal in this case. When we divide rational expressions, on the other hand, we need to know the values of the variable that is present in the rational expression in order to be able to evaluate it or to find the numerical value of it. So, for example, if you have 3 over x, you cannot evaluate it if you do not know what the value of x is. So that's a rational expression. And as examples, I'm going to take, for example, x equals 1. So if x equals 1, then we'll have 3 over x equal to 3 over 1. That is 3. So if x equals a negative number, and I'm going to take as an example negative 3, we're going to say that 3 over x would be 3 divided by negative 3. So the answer is negative 1. So as you can see, we can find many values of x. We can substitute into the equation and evaluate what the rational expression 3 over x. However, there is one value that x cannot be given. And I would like you to pause for a second and think about it. What is a value of x that x is not allowed to have in this particular expression? So you have probably come up with the idea here, and I will bring to your attention the famous number 0. So if we allow x to be equal to 0, then 3 over x will turn into 3 divided by 0, and that is undefined. Because division by 0, as we all know, is not defined. In this case, we are going to call the value of x equals 0 a restricted value for x in this particular rational expression. So in this case, then, we will have to lay out a restriction and state that there is a restriction in this rational expression, and the restriction is that x cannot equal 0. And cannot equal 0 or different than 0 is this little symbol with the equal sign and a slash line. Now let's move on to the next question. So x plus 1 divided by 5x. Again, as you can see in here, if we give the x any value, we'd be able to evaluate this expression. So we're going to say that if x is equal to 1, then x plus 1 over 5x will turn into 1 plus 1 divided by 5 times 1, which is 2 over 5. In a similar way, if x equals, let's say, for example, negative 10, we're going to say that negative 10 plus 1 divided by 5 times negative 10 is equal to negative 9 divided by negative 50, or simply 9 over 50. So next, I want you to think, is there a value of x that this expression is not allowed to have? Now, as you probably notice in here, when we talk about values of x that a rational expression is not allowed to have, are the values of x that can make denominator 0. So our focus should always be in the denominator, and our denominator in this case would be 5x. So the shorter way or the quicker way to get to the restricted values of x is by looking at the denominator, in our case 5x, and making the statement that 5x has to be different than 0. Now we have to isolate x, and when we isolate x, we isolate it just like we do in an equation. So divide both sides by 5, and that will give x different than 0. So the restriction in the next expression here is, again, x different than 0, similar to the restriction in 3 over x. Now we're going to take a look at another example. So what we have here is 2 divided by x minus 4, and our focus is in finding just the restricted values of x, or the restricted value of x. So again, we're going to focus only on the denominator. Remember that the denominator has to be different than 0. And with the denominator of x minus 4, then we're going to say that x minus 4 has to be different than 0. Now, when we state restrictions, we state the restrictions on x, which means that we have to isolate x by simply solving this. I wouldn't call it an equation, right? So, but by solving this statement as an equation, so take negative 4 to the other side, and we'll say x different than 4. And that would be the restriction in our case. It's a very common misconception of people thinking that x cannot equal 0 if you have a rational expression. Remember, it is not x different than 0. When we talk about restrictions, we talk about the denominator in a rational expression. So the denominator has to be different than 0. So we're going to continue with the next question, and we're going to work a little bit faster. So in this case, we are stating restrictions on 5 divided by x times y. So the operation between x and y here is multiplication. Oops. So what that means is that, remember, in multiplication, if either factor, because x is a factor here and y is a factor, so if either factor equals 0, it will make the entire product 0. And our denominator is in product form here. So we're going to say that x has to be different than 0 and y has to be different than 0. So in this case, we have 2 restrictions. And that is because in this particular example, we have 2 different variables. So we're going to say x different than 0 and y different than 0, because if either one of them becomes 0, then it will make the entire denominator 0 and the expression undefined. Now, I encourage you to try this on your own, and you will be so good at this in no time, really, because they're very easy. Identifying restrictions is quite a fun and easy task, actually. So if you want to state the restrictions on this particular expression, again, focus on the denominator. And we're going to say that the restrictions, and normally when we do or when we practice homework or even on a test, We don't write the whole word there. We just write x minus 2 different than 0. So x different than 2. So the restrictions would be x different than 2. Now let's take a look at this other example, which is different than the previous ones. In this case, we have two binomials in the denominator, and they are in the form of a product. So the product of two binomials. So remember that if either binomial becomes 0, say for example, if x minus 4 becomes 0, then 0 times anything, right, would be equal to 0. So that tells us that x minus 4 has to be different than 0. Similarly, we're going to say that the other binomial, which is the other factor of the denominator, x plus 1, also has to be different than 0. So we're going to say x plus 1 different than 0. So therefore, we're going to say that the restrictions in our case would be, obviously, we have to state the restrictions on x. So isolate x different than 4, and x different than negative 1. And that's exactly what we want to write, different than 4 and x different than negative 1. And some people like to write this as well. So x different than 4, comma, negative 1. And that is totally fine. I encourage you to, for now, just use, separate the restrictions from one another, because you don't want to confuse yourself sometimes with, when you write the numbers very close to each other, and then you assume that it's some decimal number in there. So this is the idea behind restrictions, and we're going to find restrictions in various rational expressions. Now, examples that we looked at are examples where the denominators were given in factored form, right? But sometimes we will have to factor the denominators. And for this, we're going to take a look at some more examples in the next video. But before you leave, remember that restrictions are the values of the variables that will give the entire denominator a value of 0. So 0 is not the restricted value of x, but the value of x that makes the denominator 0 is the restriction. Thanks for learning with me. Bye for now.